simultaneously you can also practice. I have shared you with some files. So let's start with objective. So objective may be univariate, maybe bivariate, maybe multivariate. What does it mean? Objective may be univariate, bivariate, and multivariate. What does it mean? When we frame the objective, we have to see what does it mean. How many variables are there in the objective? If we are not, aware about the nature of variable, nature of objective, then we will face the problem in our research. So univariate means only one variable is there. Let's say to study the satisfaction level of participants of this FTP. So in this, what is the variable? Yesterday we have discussed a lot about variable. So if somebody can answer me, I'm telling you the objective to study the satisfaction level of participants of this FTP. I'm writing here to study the okay, tell me which one is variable in this objective?
So participants
Sir,
satisfaction.
level.
Participants and satisfaction.
Participants satisfaction. Yeah, satisfaction
Okay.
of participants.
Okay. So only satisfaction. Satisfaction is variable here. Satisfaction will vary from one participant to another participant. Other things will remain same. Okay. Any doubt? So this is univariate. Only one variable we have in our objective. Is it clear?
Yes, sir.
Now, bivariate. Bivariate means there are two variables in this study. Can anybody reframe this objective as bivariate? Anybody?
Like to study the satisfaction and motivation level of participants of this FTP.
Very good. We can study satisfaction level and motivation. Okay. Very good. Any other objective out of this objective which can become bivariate? Okay. Can we say that to study the satisfaction level of male and female participants of this FTP? Can we study? Hello?
Yes, yes, sir.
Oh, okay.
It
So
can
how
be
many-
studied. Yes.
How many variables are there?
One only.
Two variables. One is satisfaction, another one is male and female, gender. So first is satisfaction level, second one is your satisfaction level, and another one is gender. Okay. Now, what is multivariate? What can be the objective? Anybody? No? Okay.
Sir, more than two variants are going to be
More than
added, then we can say it
Very
as a multivariate. Yeah?
More than two. So to study or to find out the factors affecting the sales of the company. Okay. In this case, if we have more than two variables, then this will become multivariate. Yes, Priyansu. Priyansi?
Sir,
Priyansi?
sorry.
Nothing. Okay. So is it clear? Is it clear? Now, move. These are certain model objectives. What you should do under these circumstances. If you are writing to predict, to forecast, to model, then you must, or it is advisable to use regression in your analysis. So yesterday I told you, once you have framed your objectives, you don't have any choice. You have to go as per the instructions of your objectives. So if you have written to predict, to forecast, to model, then it is advisable to use regression in your study. If you are sorry, if you are writing to compare, to differentiate, you should go for hypothesis testing. You should go for hypothesis testing. If you are writing to determine, to find out factors influencing model review, then you should go for respondents to collect the data and to use exploratory factor analysis or confirmatory factor analysis. So these are some suggestions. I'm not saying that these are hard and fast rules, but these are some suggestions. Your objective will guide you what you need to do, which test you need to apply. You cannot apply test, you cannot go as per your choice. Okay, let's move ahead. Now come to the topic of hypothesis. Again, hypothesis may be univariate, maybe bivariate, or maybe multivariate. Okay. What is univariate? Univariate means we have to apply one sample t-test. Only one sample we have to apply one sample t-test. We will apply all of them in second half of the schedule. Bivariate, two independent samples are there and we must apply two independent sample t-test. Multivariate, we should go for paired sample t-test. Now, when we write the hypothesis, we must choose the words very carefully. Should we write, relationship, or should we write difference? We have to see on this today. We have to understand what does it mean by difference or maybe relation. Where we should use difference word, where we should use relation. So what is null hypothesis? Yes. Yes, madam.
Sir, please be asked, how do you decide that what type of a test you are going to apply? Like for univariate, you have written one sample t-test. So how do you decide that what are the tests you are going to apply for those variables?
If you have only one sample from the population, what may be your objective?
On the basis of objectives, how do we decide it?
On the basis of objective, how we decide?
Yes, sir.
Okay, so suppose I'm interested to know the satisfaction level of participants of this FTP univariate objective. Okay. Okay. So this one.
Yeah.
So what will I collect it as data?
The satisfaction level of the students.
Satisfaction level I will collect. Then what will I do with that? I have collected the data.
Yes.
on 5-point scale or on 10-point scale, how satisfied you are. Okay, please rate from 1 to 10. 10 means highly satisfied, 1 means you are not satisfied at all. So somebody has take 6, 7, 5, 4, 3, 8, 9, 10, whatever they have. Out of that data, what will I do?
Try to find out the satisfaction level.
How?
We need to find mean.
I will find out the mean, then then I should infer whether this mean age. I will, yes, I will
Comparing means
compare. Oh, with what I will compare, because I have only one sample.
So can we take the number of participants in this one?
Number of participants in that.
Data. During data collection, number of participants, what we will answer?
Okay. Okay. So for that purpose, what I need to do before going to the survey, I will determine some parameter. If I get a mean that is more than 7, I will assume that participants are satisfied. I have to set this standard. If 5 to 7, they need some more, inputs. If the average is less than 5, then I will say that participants are not satisfied at all. What I will do, after collecting the data, I will calculate the mean and I will check it against my claim, against my parameter. So in this way, univariate, we will apply one sample t-test. In the second half, we will discuss this. So if you can hold for 40-45 minutes, then it will be fine. So we will do such kind of analysis for univariate, bivariate, and multivariate also.
Okay.
Okay.
Yes.
I will explain once again. Don't worry. Now come to hypothesis. So what is null? Null means there is no difference or there is no relationship. So my dependent and independent variable, or what we should do, what we should say, not dependent, independent, both the variables are same. Both the data set are same. There is no relation, there is no difference. Alternatively, what we say, x is less than y or x is more than y, means there is a difference. And if I say directional hypothesis, what does it mean? X leads to y or y leads to x. So this is directional hypothesis. So whenever we frame hypothesis, we must remember these things. Now come to the word difference versus relation. When we should use difference and when we should use relationship. Okay, tell me. There is no significant relationship between marks and income. There is no significant difference between marks of boys and marks of girls. We should not write it as there is no significant difference between marks and income. So please read it carefully. We can write there is no significant relationship between marks and income. And we can also write there is no significant difference between marks and marks of boys and marks of girls. But we cannot write there is no significant difference between marks and income. Can we write it like this?
no,
No?
No, sir.
No. So what is the thumb rule? Where should we use the word relationship and where should we use the word difference? What is the thumb rule?
Here, relationship, we can say to check the relationship between the marks and income of different age groups or something like that. Then the word relationship can be used probably.
You are right. But
The
what is the thumb rule to use relationship and difference?
relationship is like how one is related with other. It may be there may be a positive relation, negative relation. Difference is like the what like how much marks boys are getting, how much marks girls are getting, and the difference between them is significant or not. It is not. I think it is not a bivariate thing.
Okay.
Here we are just talking about one variable marks.
Okay. Okay. Thank you. Thank you. I'm summarizing this only. When we use the word relation, okay, it means both variables are different. They are not similar. So different things can be related, means we can find the relationship between two different things. Marks and income, both are different things. And we can identify the relationship between two different things. While marks of boys and marks of girls, both are similar things. Marks of boys and marks of girls. What we are comparing? Marks. Okay, so marks are same thing. So similar things can be differentiated, while different things can be checked for relationship. So this is the thumb rule. I'm repeating once again. Different things can be checked for relationship, while similar things can be differentiated. So this is the thumb rule to use the word relationship or difference. One more thing, when we use use the word difference, it means one variable is categorical, non-metric, like gender, boys and girls. One variable must be your categorical variable, and it must have more than one category. So if we are doing like that, we should use the word difference, otherwise relationship. Now your questions.
Sir, can you please explain? I couldn't understand.
Which one?
The difference versus relations.
Okay. Sir, I said two different things can be checked for relationship. For example, marks and income, these two things are different. So we can check for relation. Sorry, we can check for relationship whether they are related or not. Is there any relationship between income and marks? Higher income, higher marks, lower income, lower marks, or vice versa? We can check for this. But the marks of boys and marks of girls are similar thing, same thing. So we cannot check for relationship. We can check for the difference. Is there any significant difference between the marks of boys and marks of girls? So say similar things can be differentiated, but different things can be checked for relationship.
Thanks, sir. Thank you.
Okay. Any other question? No.
So can you please show the last slide, the previous one, previous slide, yeah, just before
Yes.
this.
Yes.
The directional, sir, this directional hypothesis you said.
Yeah.
So if I say like higher psychological capital is the, and people with higher psychological capital can have higher happiness score. Is this directional hypothesis?
Yes. And you will check this and you will prove prove whether hypothesis is accepted or not accepted.
Okay, thank you so much, sir.
Okay. Now come to. So whatever I have explained, I have written here. So no meaning to read it again. Now, in case of difference, if we have used the word difference, we should use tests to check whether two or more things are same or not. Like we should apply t-test, z-test, f-test, etc. In case of relationship, if we have used relationship word in our hypothesis, what we need to do, we must use techniques like regression and correlation, etc. Okay. In case of tests, the table value at 5% is maximum permissible difference because of chance. In social sciences, we use the confidence level 95%. Do you know? 95%. Why we allow for 5%? Generally we check against 5%. It means the value up to 5% is permissible, because that difference may be because of chance. So we ignore that. If the difference is more than 5%, then we should say that there is a significant difference. Always we use the word significance. Okay, difference is there, but difference is significant or not, that will be checked against the 5% value of P, means 95% level of interval. So
So
if
what is confidence level?
sorry,
What do you mean by confidence level?
95% confidence level. It means with 95% confidence, we can say whether my results are, my hypothesis has been accepted or rejected. 5% we allow for, by chance difference. In social sciences, what we see, in every test, what we see, if p-value is less than 0.05, what does it mean? Less than 0.05 means 5%. So we always check for 5%. And software calculate it for us. But if software is not calculating for us, if we want to calculate manually, then we can also calculate manually. How? If the calculated value is less than table value, it means no significant difference. In this case, p-value must be more than 5%. If calculated value is greater than table value, means there is a significant difference. P-value must be less than 0.05. So up to the table value of 5%, this is the acceptable limit. We say that this difference is because of chance. The difference is not significant. Okay. Now come to the scale.
Excuse me, sir.
Yes, please.
Sir, the confidence interval can be 95 and at some cases 99 also, right, sir? Because the p-value, like what you said, 0.5, it can be also 0.01, right?
Yeah. Sir, what happens in medical sciences, we generally take the p-value less than 5% also, means, confidence level of
Confidence interval.
more than
Confidence
99% also. But
Okay.
sometimes it happens in medical sciences also. If confidence level is 70%, then we can move ahead also. If you have
Okay.
seen in the case of coronavirus vaccine, the
Mhm.
efficacy level, some vaccine was having 70% efficacy, some vaccine was having 80% efficacy, because we do not have any option better than this. So we applied that vaccine.
Okay, but it is a rare case scenario, right?
A rare case, but rare case. But in social sciences, what we do, generally we use 95% confidence level. Sometimes we use 90% also.
Okay.
It depends on the study. If you are, meeting the criteria of 99% confidence level, then the study is very good.
Okay. That just wanted to clarify that, sir. Thank you.
Yeah. Okay. Now we must understand scale. What is scale? When we collect the data, we must be aware about the scale and how we should frame the questions and what we can do with this, question. So before framing the question, we must understand, if I frame the question like that, what I can do with this data. So be careful. Sometimes, we do a lot of exercise in collecting the data, and after collection of the data, we find that we cannot do, much with this data. So understand the nature of the scale. One scale is nominal. Nominal is non-metric and non-parametric. Nominal scale means non-metric and non-parametric. Second one is ordinal, or we can say rank. This is also non-metric, non-parametric. Next one is interval. Interval scale is metric and also parametric. Ratio scale. So this is metric and this is parametric also. So as we are going to discuss today parametric tests, tomorrow non-parametric. So try to understand, parametric test can only be applied in parametric data. Parametric test cannot be applied in non-parametric data. Okay. Non-parametric tests can be applied in any kind of data, but parametric tests can only be applied only in metric and parametric data. Also, please remember, after satisfying certain assumptions. So, is it clear? The scale, nominal, ordinal, interval, and ratio. Now, come to this, measurement. There is a big question: what kind of data will be, and what test we can apply, and all these things. If you have nominal data, what kind of questions you can ask? You can ask MCQ question or binary question. MCQ question or binary question. Male, female, 1, 2. Tick. Okay, this kind of question you can ask. These are, closed-ended categories. The respondent does not have any option to write from his or her. Only the respondent can tick the option which you have provided. In ordinal, what can you do? This is MCQ, binary, rank, Likert, if you have given 1, 2, 3, 4, 5. Okay, so individual statements. These two categories are close-ended, non-metric, non-parametric. What you can do with this data, you can create chart, bar chart, pie chart. There is no continuity in this kind of data. Normality cannot be checked in this kind of data. Nominal and ordinal data. So is it clear? Is it clear?
Yes,
Hello?
yes, yes.
Yes, sir.
Now come to interval data. Data grouped in the categories. You have created categories, age group. Okay. 0 to 10 year, 10 to 20, 20 to 30, like income groups, like that. This is open-ended data form. Actual units also you can measure. Metric data, you can create histogram. Possibility of continuity is there. If continuity is there, then you can create histogram. If continuity is not there, you can create only bar chart. Ratio data, this is open-ended data. Data from any database, financial data, which you have collected. This is known as ratio data. Normality can be checked. Normality may be possible or may not be possible, but we can check for normality in case of interval and ratio data. Now come to the question of normality, skewness and kurtosis. How we check the normality? First of all, we will understand theoretically, then we will go for practical exercise. So if you have any kind of doubt in this measurement, you can ask the question, or should I move ahead? Any doubt, any question?
Excuse me, sir.
Yes.
Yeah, sir. Actually, as you said that in case of interval and ratio data, normality is possible or either not possible. So, in case if we don't get a normal data for normal curve for these data, so that means our test will not be successful or it will not be right.
Actually, every test has certain assumptions. If assumptions are met out, then only we can go for the particular test. Otherwise, we have other options. It does not mean that if normality is not there, we cannot do anything with the data. We have alternative tests.
Okay. Okay, sir. Thank you.
Am I clear?
Yes, sir.
But the
Maybe in
question
further
is,
explanation we'll understand.
yeah, definitely. I will tell you. If data is not normal, what you can do with the data also, I will tell you. But the point is, in nominal and ordinal, you cannot even check for normality. In interval and ratio, you can check for normality, whether data is normal or not.
Yes.
Any other question? No? Now come to the point of normality. What does it mean by normality of data? Anybody? Anybody? What is mean by normality of data?
When the data is following normal distribution.
Very good. When the data is following normal distribution. Let me
When you get a bell-shaped curve.
Bell shape, yes.
bell-shaped curve. Very good. Bell-shaped curve. Okay. Very good. Normal distribution. Okay.
Mostly
So,
all variables quality, right?
yes. Please, please. Hello. Please speak.
Yes, that's what I said, sir.
Okay. Okay. Thank you. So, first of all, we will see theoretically, then we will check, we will apply this with the help of the data which I have shared with you. So, this is frequency polygon. Can you tell me whether data is normal or not? And what is the problem with this data?
It's skewed data.
Sorry,
This is
It's
not
skewed
normal
data.
distribution.
it's skewed. Okay.
Yeah.
Which side is skewed?
Right side.
Right side is skewed. Only skewed. Only skewed.
Six.
Okay. Now tell me. This is the ideal
Normal distribution.
ideal bell-shaped curve.
Bell shape.
Okay.
Yes.
So if we see one standard deviation, 68% data must be covered within this -1 + 1. Two standard deviation data 95% must be covered within -2 2 + 2. 99.7% data must be covered within -3 2 + 3. So if area of both sides of mean is equal, so this is mean 0, this is mean, and area both the side is equal and same, it is known as equal and same. It is known as symmetrical distribution, symmetric distribution, and this is the normal distribution curve, bell-shaped curve, which we know as the normal distribution. Okay, this is skewness. Actually, what we do, we check skewness, we check kurtosis, but sorry, sometimes we do not know the meaning of skewness and kurtosis. Skewness means the data, more data is on one side of mean. Like in this case, this is the mean. Blue line is the mean. Sorry, this yellow line is mean, and this green line is median, and blue line is mode. And you can see the data is left skewed. The maximum data is on the left side. In this case, maximum data is on the right side. So this is left skewed and this is right skewed. So in the non-normal data, what we see in the previous figure, what we see? Mean value. So data must be equal on the both side of the mean. But in non-normal data, what we see? Do we check mean or something else?
More, sir.
So, no. Anybody else?
So please repeat your question.
In normal data, we compare the values with mean. In the previous figure, what we have seen, what we are saying that the half of the values are left to the mean and half of the values are right to the mean. But in case of non-normal data, do we compare this with the mean or something else?
So
Median. This is
I think with skewness.
this is median. So we compare the data with median. We see the median in non-normal data. In normal data, what we see mean. In non-normal data, we see median. So this is the distribution to the both side of mean is not equal. That's why these graphs are showing that the data is skewed. So in such kind of data, we should see median, not the mean of the data. Okay, now come to this. So all three graphs are representing a normality of data or something else.
No, not normal distribution.
Sorry,
All are not normal distribution.
all are not. Why? The half of the data is to the left, to the mean, and half of the data is to the right of the mean.
No, but the middle one, like for example, blue, it is really covering a very, you can say, less percentage
Okay.
of the
Median
population.
value is
Because the
different.
peak is very high, as we can see.
Which rule is violating here?
Median.
Which rule is violating here?
Mean is equal to median is equal to mode.
Okay. Okay.
So the graph is.
I think
like
all three are
steeper. The graph is steeper.
normal. It's the one they have one less dispersion, the variance.
Okay. So if you remember this, the values here, 68% of data within -1 to +1, 95% data within -2 to +2, and 99.7% data from -3 to +3. So this rule violates in this, graph. What happening? Either in leptocratic distribution, peak is very high. It means maximum data is near mean. Maximum data is near mean. But in case of platicratic, what is happening? The data is away from mean. Data is away from mean. So in this case, if peak is high, then leptocratic distribution. If peak is below the normal distribution, then this is known as platicratic distribution. So this is known as kurtosis, and this is known as skewness. So whenever we check for skewness and kurtosis, we must keep in mind what is meant by kurtosis and skewness. Is it clear? Hello, is it clear?
Yes, sir.
Okay. Somebody was asking, if my data is not normal, what should I do? Sapna madam?
Yes, sir.
You were asking, if my data is not normal, should I leave it or should I apply some test? So some suggestions are here. If your data is not normal, to make your data normal, not a guarantee, but suggestions are there. Advisable. In finance, if data is not normal, make it normal by transforming as log or inverse. You can take the log of the data, or you can inverse the data to check for normality. Maximum times after taking log or inverse, data becomes normal. So we have mechanism. Is it clear? If data is platicratic, take 1 by x. X means data. If data is leptocratic, take under root. If it is skewed, then take log. So there are certain suggestions available how to make the data normal. This is no guaranteed method, but only suggestion is there.
So what's the meaning of platicuratic and leptocuratic?
You missed it. You missed it. Leptocratic means peak is very high.
Okay.
Platicratic means the peak is less than the normal.
Right.
Okay. Now,
Sir,
any question? Any
excuse
question
me,
till
sir?
now?
Excuse me, sir.
Yes.
Sir, it means that when we check for the normality using the Shapiroval test, and if we don't get the data as normal, we can use these methods to normalize our data as much as possible.
Which data? Which data? Which data?
The parametric, the interval or ratio data.
But which kind of data?
That we
This is the measurement scale only. Which kind of data? The data related to finance. Respondents data, you cannot apply these techniques. And sometimes it is not required to check for normality also. Okay, I will tell you in coming sessions. Sometimes it is not necessary, and you should not check for normality of data. Okay, I will tell you.
Sir,
Okay.
sir, if it is social sciences like
Okay, in case if
psychology,
we,
data,
if
sir.
it will be good if we take some practical example in the later class.
Sorry.
It will be good if
So
we take some practical example and test for the normality and
definitely we can check for normality today itself. I have shared with you the file.
okay.
We will do.
Okay,
Yes,
okay.
sir, please.
Yes, sir. If it is in the case, this is the finance data, sir. If it is in the case of psychology, so what are the other ways that we can go with the normalization, sir?
Sir, if the data has been collected from the respondent as primary data, then sometimes it is not required to check for normality. Okay.
Okay. So for primary data, it is most of the time it is not necessary.
No,
right?
I'm not saying like that. In some kind of data, it is not required.
Okay,
Okay.
sir.
In some kind of test also, it is not required. In particular tests, it is required. So if we are applying those tests, we must go for normality. If we are not applying those tests, we should not check for normality. And certain kind of data cannot be checked for normality also.
Okay, sir.
Okay.
In that case, you can go for a non-parametric test, right?
No, outrightly we cannot say like that. For example, Likert scale data. Yesterday we have discussed factors like for honesty. How will you collect the data? I will discuss today the type of questionnaire, type of questions also. So I will tell you, if you are collecting the data on 5-point scale, the respondent will answer 1, 2, 3, 4, 5, whatever, 1 to 5. So in that case, you need not to check for normality of data. And you should not if you are applying for factor analysis. So I will tell you that is metric data. That is metric data, but you should not go for checking of normality of data because you are applying EFA. So I will tell you which test to apply where. So please hold on for some time. So what is normality of data? Are you clear about this? Now come to analysis. Analysis is also univariate, bivariate, multivariate. Univariate means you have only kindly repeat. Okay. If you are applying EFA, you are not required to check the normality of Likert scale data. Please listen once again. If you are applying EFA on Likert scale data, you need not to check for normality of data. If you are applying EFA on finance data, you must check. Sir, normality checking is not the requirement of the test in Likert scale data. That's why we do not check and we should not go.
Okay.
Okay. Now come to the univariate, bivariate, and multivariate analysis. I will tell you what is the meaning of bivariate analysis and what we can do with this kind of data. Univariate analysis, if data is metric, what we can do, we can calculate mean, we can calculate standard deviation. For example, to study the satisfaction level. So earlier also we have discussed, if I collect the data of satisfaction level, I can calculate mean, I can calculate standard deviation, and I can check it with the standard value. Nothing more we can do with this kind of data. What we can do, we can apply one sample t-test also, only to check the claim after mean and standard deviation. In the case of hypothesis like weight of packet of biscuit, we will do this exercise with the help of 3 data sets. So I will tell you. Non-metric data, what we can do, we can only count them. We can only calculate the percentage. For example, if I am asking you the question, are you satisfied? You will say yes or you will say no. So I can count how many said yes, how many said no. And what I can do, I can calculate percent also. 30% are satisfied, 70% are not satisfied. So before going to collect the data, we must have clarity in our mind what I can do with such kind of data. Otherwise, collection of data will be, wastage of time, and you will not get whatever you want to do. So this is univariate data. If data is metric, I can calculate mean, standard deviation, one sample t-test for hypothesis testing. If data is non-metric, then I am able to calculate only count and mean. Sorry, count and percentage. Bivariate analysis. Bivariate means there are two variables. One is dependent variable, another one is independent variable. So if both are metric, okay, dependent and independent, both are metric, then I can calculate simple regression to check their relationship. Is it clear? Is it clear? Hello?
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
Okay. If my dependent variable is non-metric and independent variable is metric, then I can go for LDA. I can go for linear. LDA means linear discriminant analysis. Linear discriminant analysis. So I can go for that. If my dependent variable is metric and independent variable is non-metric, what I can do? Hypothesis testing, t-test, one-way ANOVA to check for differences. If both are non-metric, dependent as well as independent, then I can apply cross-step, I can apply chi-square. I think it's clear. Univariate analysis and bivariate analysis.
Yes, sir.
Yes, sir.
Now, so during the course of this FTP, sometimes I will discuss about multivariate analysis also. Look for the objective. Maybe separate questionnaire for separate objective is required. Like if you are collecting the data from employee and employer and you are collecting the data on the same questionnaire, will it work?
No.
No.
And who will tell me the separate questionnaire is required?
Yeah.
Who will
it is
tell me?
required.
Hello?
It is required. Separate question.
No, who will tell me?
Your objectives.
My objective.
Yeah.
My objective. So who is guiding me? My objective. So you must be clear. You must be, what I need to say. You must be aware what are you writing in the objective. Objective tells about variable, context. Variable tells about measurement and the data. Will it be primary or secondary? So I do not have any choice after framing my objective. I have liberty, I have choice at the time of framing my objective only. If objective is clear, I need not to go here and there. I will go in the direction which is suggested by the objective. If objective is not clearly defined, I will not end it up anywhere. Now, this is one questionnaire, how I will, frame my questionnaire. So question 1, let's say I'm giving the question like gender, male, female. How respondent will respond here? How respondent? Yes.
Choose one option.
Choose one option, either tick on male or female. Okay. Question number 2, age group 20 to 30, 30 to 40, 40 to 50.
Range.
Again, tick. Question number 3, qualification UG, PG, PhD. Okay.
Same.
Same.
Yeah.
Question number 4, experience in months.
Numeric figure.
Okay. Value. Question number 5, rank the following: Ramayana, Mahabharata, Gita. Please tell me how many questions are there
5.
in the highlighted area. How many questions are there?
One only.
Only one question. Only one question. No. How 3 questions?
Rank of all. Okay, because they have to rank. They have to tell out of 3 which one is Ramayana is first or second or third or same. So,
If I tick 1 to Ramayana, then I cannot tick 1 to Mahabharata and Gita.
yes, order kind of.
Okay. So only one question is there. So at the time of framing question, I must be very clear. Then I am saying rate the following: highly satisfied, satisfied, neutral, dissatisfied, highly dissatisfied. TV, mobile, car. How many questions are there?
One only.
One.
No, 3 this time.
3 questions.
3.
Separate questions. Okay.
3 questions.
Okay. So we must be clear when we are framing the questionnaire. Okay. How we will do the coding of these questions? So this is the coding, data processing coding. I will give 1 to this option male, 2 to female, age group 20 to 31, 30 to 42, 40 to 53. Qualification if UG 1, PG 2, PhD 3. And I cannot give any ranking to this question, any coding to this question, because this is open-ended ratio question. And 5 point, this is the ranking question. So whatever the rank will be given by the respondent, that will be my coding. So rate the following. I'm satisfied with TV. I'm satisfied with the mobile. I'm satisfied with the car. So how will I rank them? 2, 2, 2. Because all of these are separate questions. So is it clear why I need to give the coding?
Yeah.
Why I need to give the coding to the responses?
Yes, sir.
Why I am required to give the coding?
To count
To
the
get the
responses.
nominal data, we cannot write with the answers which is
Yeah.
here. So 1, 2, 3, that is the nominal data.
Because when I will enter the data into the software,
SPSS, it will not accept it.
yeah, I need to enter that code only.
Yeah.
Every time I will not write male. Every time I will not write female. What I will write? 1, 2, 1, 1, 1, 2, 2, 1, 2, 2, 1. Like that, I will write only.
Assigning values.
Yes. So for that purpose, I need to give them codes. Now, this is the format of entering the data. We will do practically. This is the format of entering data. In 1 row, there will be 1 respondent, and in 1 column, there will be 1 question. Am I clear?
Yes, sir.
1 row will represent 1 respondent, 1 column will represent the responses of 1 question. Any doubt to anybody?
No, sir.
Okay. Should we go ahead?
Yes, sir.
Okay. So now we will apply parametric tests, and we will check for normality, and we will apply t-test and ANOVA today. So parametric test, before going to the parametric test, we must understand the meaning, nature, the prerequisite to apply parametric test, assumptions of parametric test, everything we must understand. So big question is when to use parametric and when to use non-parametric. Anybody has any idea when to use parametric and when to use non-parametric?
When its
Depends on
variables are
data.
following
Depends on
normal
data.
distribution, then
One
we
by
use
one,
parametric.
everyone has the opportunity to speak, but one by one. Yeah, please, madam. Complete.
When our variables generally follow normality, then we use parametric test, right?
Okay, thank you. Yes. Pandey sir, you want to say something?
So it depends on data actually.
Okay. Anybody else who want to add something?
So when there is a linearity,
There is a
linearity.
linearity. Okay. Anybody else who want to say something? Anybody else who want to say something? No. Okay. So if we meet the assumptions of parametric tests, then only we can apply parametric test. Otherwise, we should go for non-parametric test. The only answer is that if we meet the assumptions of parametric tests, then only we can apply parametric test. Otherwise, we should go for non-parametric test. Means if we fail to meet the assumptions of parametric test, we should go for non-parametric test. Now the question arises, what are the assumptions of parametric test? So let me emphasize on this. Once again, I'm emphasizing on this scale. So measurement, nominal data may be classified or grouped like gender, marital status, color of car, etc. So this kind of data is nominal data. Ordinal data must have some order like income groups, like qualification. In this data like gender, male and female, no one is greater than the other category. Can we say that one category is less than other or one category is more than other? No. So there is no less or more, and marital status, married, unmarried, whatever. But there is no, less than or more than. But in the ordinal data, there is order. One is less, another one is higher. For example, qualification. We can say 12th is less qualified than graduate. Graduate is less qualified than postgraduate. And postgraduate is less qualified than PhD. Can we say or not? So there is a order. Income group. The income group 0 to 1 lakh, 1 to 2 lakh, 2 lakh, 3 lakh, 3 lakh to 4 lakh. We can say that person having income 4 to 5 lakh is having higher income to the person who is having 0 to 1 lakh income. Interval like breast size 30, 32, 34, 35, 36, 38 like that. So these are known as interval data. Ratio scale data when 0 makes some sense. Okay. For example, 0 sales means there is no sales.
Yeah.
Just 1 minute, sir. So sales or other financial data, this is ratio data. Yes, sir. Please ask question.
Sir, in interval data, it should be equal interval, right? So like 10 to
Which
20.
one? Which one?
The interval. Interval is like the value must be between 10 to 20, 20 to 30. So the interval is 10. Is it right, sir?
Sir, here one condition is that the difference between two groups must be equal.
Equal,
If
yeah.
difference is equal, then we can say this is interval data.
Yeah, I mean that, sir. Thank you.
Otherwise, no.
Okay.
Now, on the basis of scale, parametric and non-parametric, which kind of data is eligible for which kind of test? Nominal data, ordinal data, both are non-parametric and we cannot apply any parametric test. I'm saying we cannot apply and we should not try also. But if we have interval and ratio data, after meeting the assumptions of the test, we can apply parametric test. But non-parametric test can be applied in any kind of data. So if we fail to meet the assumptions of parametric test, we go for non-parametric. If we meet the assumptions of parametric test, we should go for parametric test. So concept of normality we have understood theoretically. Now statistically we will check for the normality. With the help of graph, what we can do? Visual winning graph, bar chart, we can check. Box plot, PP plot, equal plot. Statistically, what we can check? One sample KS test, skewness, kurtosis, Z score of 5%, trimmed mean. We will do this exercise with the help of the data. So I have shared one file with you, that is the file name is file for normality. Do you have that file? File for normality.
Yes, sir.
It's normality test.
Normality test. Yes, normality test. You have that file?
Yes.
So what I need to do, I need to share my entire screen. Wait for 1 minute and I will apply this test. Okay, I think this data is visible to you.
Yes, sir. Visible.
Visible?
Yes, sir. Visible.
Okay. So this is data like engine size, horsepower, curb weight, fuel capacity, or MPG. So this data is related to any automobile company, and we have observations for how many observations we have? We have 157 observations. Okay, are you able to see?
Yes.
Okay, we want to check whether this data for every variable, these are my variable: engine size, horsepower, curb weight, fuel capacity, MPG. These are my variables. If you are aware about this SPSS, you must know we have two tabs, data view and variable view. In this variable view, we have entered our variables. We have given the description of variables. Engine S means engine size, horsepower means horsepower, curb weight, fuel cap means fuel capacity, MPG means fuel efficiency. So this is the data, and I have entered the data in data view. So I have 5 variables. I want to check them for normality. Normality will be checked for variable wise. Okay, normality will be checked for variable wise. Are you getting my point? So what test I have discussed? First one is graphically. So I will go for visual winning. So if you want to remember, you can remember. Otherwise, recording will be shared with you. Go to transform. You have the option of visual winning. Go to visual winning. This box will be opened. I will transfer all variables to variable to win. Then I will say continue, and I will get this window. Can you see? Is it visible to you?
Yes, sir.
Yes, yes.
Yes, sir.
So this is for engine size. This is for engine size. So can you tell me whether data is normal or not?
No, no,
No.
normal distribution. Left cut also is there. Left is skewed.
Left is skewed or right is skewed?
Right, right skewed, sir.
Right.
Okay. Now go to horsepower. If I click on the particular variable, this bar chart will change. So can you see?
Yes, sir.
So
Almost normal.
so this visual winning is suggesting me that my this looks somehow like near normal,
Yeah.
but others are not normal. So first method is graphically I am testing with the help of visual winning. Any question till now? No.
No, sir. All
So
clear.
please repeat your last line.
Last slide.
Line. What did you say last?
I said that we have checked this graphically, and one method is visual winning. Other methods are also there for graphically checking, but one method is visual winning. I'm going to other methods now.
Visual varying.
Visual winning.
Okay. Winning.
You can see this here. Visual winning. VINNIA. Okay.
Hmm.
Now I'm going to other methods. I will go to analyze, descriptive analysis, explore. Please listen. I will go to analyze, descriptive statistics, explore. What will I do? I will transfer all the variables to dependent list. In statistics, I need descriptive, I need outlier. Okay, confidence interval 95%. Continue. Plot. I can check normality plot with tests. You can see the option here. Normality plots, QQ plot, PP plots. Plots will be here. Stem and leaf. Continue. Options. Continue. Then OK. So I will get the output window here, and I will analyze the window here. So are you able to see case processing summary? every variable has 153 valid observations and 4 observations are missing. So 97.5% data is valid and 2.5% data is missing. So I was having, you remember, 157 observations. Can you see?
So
157.
can you just please go to the one step back when you choose the descriptives?
Okay, okay, I will go. But can you see this file? 157 observations
Yes.
are there.
Yes.
But somewhere we have missing variables and my data is showing missing variables. You can see 110th for MPG is missing. So my analysis will tell me how many observations are missing. You can see this is missing. You can see this is missing. So my analysis will tell me how many observations are missing. Now this is output window. You want me to tell the last step. I will go to analyze, go to descriptive, then explore. I will transfer all the variables to the dependent list. Statistics, I will select descriptive, outliers, continue. Plot, I will select normality plot with test, stem leaf, then continue, then OK. Okay? Clear? Any doubt?
Yes, clear.
Okay. So we have calculated twice. Need not to worry. So first, I will get the case processing summary. This is suggesting me 153 responses are valid responses for every variable. 4 are missing. Now come to the next descriptive. For every variable, this is showing me the descriptive mean, 95% confidence interval, lower bound, upper bound, 5% trimmed mean, median, variance, standard deviation, minimum, maximum, range. Okay, skewness, kurtosis. So graphically, theoretically, we have seen the skewness and kurtosis. Now see statistically. So how to check this value? Can anybody tell me how to check this value statistically? Hello? Am I audible?
Yes, sir.
Yes, sir.
How to check this value statistically, whether my data is normal or not? Okay.
Is what
No,
test
the
you
graph
on
again.
this?
Okay. So I have opened the calculator. What I will do, I will divide the value of statistics by standard error. Okay. So 1.126 divided by 0.196. Okay. So if my value is more than 1.96, 1.96 is the Z score, then I can say that my data is normal. I can say statistically it is normal. If value is less than that, then I can say data is not normal. Okay. Now come for kurtosis. I think somebody has
Hello?
asked a question.
Hello?
Sir, could you
Hello?
please repeat that?
Sir. Please repeat it, sir.
Actually, table value is 1.96 Z score. Table value 5%. Table value is 1.96. If data is more than 1.96, then I can say data is normal. Otherwise, statistically, I am saying it is near normal. Okay.
Sir,
What
please
is this
repeat
figure
that
5.7?
calculation part.
I'm coming to this. Yes, tell me. Tell me. What you want to say?
Sir, actually show that chart and tell the once more the procedure, the dividing procedure. That skewness
Just
divided by standard error or what else?
Yes, sir, repeat that calculation part.
calculation
Okay.
part. Okay. Calculation part you want me to repeat. Do you have data? Do you have have you calculated?
Yes,
Yes,
sir,
sir.
I have just opened that.
Have you calculated?
Yes, sir.
Okay. You have a statistical value, or you have a standard error also. Is it?
Yes.
Divide the statistical value by standard error. What did you get?
Sir, for which parameter? Any?
For skewness and kurtosis both, separate.
Understood, sir. Understood.
Divide. And what are you getting out of it? What are you getting?
Sir, 5.67.
5.67. So I want to correct my answer. Whatever I was telling, I want to correct that.
Yes.
If the calculated value, you have calculated and value is more than 5. If calculated value is more than 1.96, please write, you can write it. If calculated value is more than 1.96, 1.96 is the table value at 5.5% significance level, 95% confidence level. If calculated value is more than 1.96, then data is not normal. Earlier I said data is normal, but correct answer is data is not normal. If calculated value is up to 1.96, then data is normal, because 1.96 is the acceptable limit at 95% level of confidence. Am I right?
So is this 1.96 the standard value always?
Madam, this is table value.
Okay,
Table
so
value.
Sir,
that means
that is,
the table value we have
standard
to
error.
see.
We always compare the calculated value with the table value.
Yes. So suppose the table value of some data set is say 2.
Table value.
Suppose, I don't know.
No. Table value at 5% means 95% confidence level. Table value will remain same everywhere. Z score will remain same. We have to compare with the table value, means the given standard. We have to compare.
Okay.
So this you are talking about the p-values, like the points.
No. P-value will software will calculate for us. So in that case, if your calculated value is more than 1.96, p-value must be 0. Below than 0.05. It means you are not accepting the null of normality of data.
Okay, sir.
Okay. Should I repeat it again?
Yes, sir, please.
Should I repeat it again? Just 1 minute. Okay, these are the results. Abhishek sir, if you have any question, please ask. Otherwise, mute yourself. Abhishek sir, if you have any question, please ask. Otherwise, mute yourself. Okay, so for skewness and kurtosis, what am I saying? If you have the calculated value up to 1.96, then your data is said to be normal. Otherwise, it is not normal. So you can check the normality of the data statistically with the help of, this. I should close this, and this is output. This is output. Yeah,
Right.
With the help of this skewness and kurtosis, then you can go for next test of normality. We have KS test and we have SW test, Saffaro-Wilk test. KS test and Saffaro-Wilk test. When to see the KS test and when to see Saffaro-Wilk test? If my sample size is less than 50, then we must check Saffaro-Wilk test. Otherwise, we should go for KMO or KS test. Is it clear? Any question?
Sir, if you don't mind, actually my signal got disconnected. How we got this data, sir? The normal value you got, no? So can you please show me that? I mean, in SPSS.
In SPSS, sir, you can note down the steps.
Yeah, please, sir.
Go to analyze.
Okay.
Okay. Then descriptive statistics.
Okay.
Then explore. Okay.
Okay, sir. Okay, sir.
Okay. So we will get this. So Saffroville test will be used if your sample size is less than 50. If your sample size is more than 50, then check for KS test. In KS test, what we see the significance level. If p-value is more than 0.05, then we will say the data is normal. Otherwise, data is not normal. Okay, 0.05 value is less than 0.05 means we are not able to accept the null hypothesis. The null hypothesis is data is normal. We are not accepting null hypothesis. It means data is not normal. If significance value is more than 0.05, then we will say, then I am not able to reject the null hypothesis, then data seems to be normal. So in the case of curve weight, I can say data seems to be normal. Okay, because significance value is more than 0.05, so I am not able to reject the null hypothesis. Clear? So we have checked graphically, we have checked statistically also.
This one.
Sir, in my software.
What is the name you told?
Test of
More than 50, less than 50?
Sir, we have two tests available. One is KS test, one is Saffroville test. Test for normality. Okay. Sir, please
I
ask your
am
question.
unable to find the test of normality.
Okay, go to analyze.
This one I didn't get set the table.
Okay, go to analyze, descriptive, then explore.
Yes, sir. So I have done
Okay.
that.
Go to statistics.
Yes, sir.
Descriptive and outliers. Continue. Go to plot. Normality plot with test. Normality plot with test.
Yes.
Then continue, then okay. Clear? Now you will get.
Yes, sir.
Okay.
Yes.
So
Thank you, sir.
we have other graphs also. Normality QQ plot size, QQ plot for engine size. If all the observations are on this line, then data is perfectly normal. If some of the observations are outside this line, that data is not, normal. Some of the values are away from normality. So QQ plot, we have this outlier also. You see, this is the method of checking outliers. So if my variables are within the upper limit and lower limit, then I will say that the data seems to be within the limit and there is no outlier. But in my case, these are the outliers. The graph is suggesting these are acceptable, but observation number 40 is not acceptable because this is beyond the limits and this is outlier, and this is suggesting me to check for this observation. Either you need to remove this observation or whatever you want to do, you do with this observation. Am I clear? Because such kind of observations create non-normality in the data.
Okay.
Done?
Okay.
Should I move ahead?
Yes.
So all the analysis for all the variables, it is given. You can check it. If you have, because I have collected twice, so all the results are calculated 2 times. Same results. Now, come to PPT. Have you checked for normality? Any doubt?
Sir,
We have
the
checked
name.
for
Sapiro will size, sample size you told I still.
If you have sample size less than 50, then go for Sapiro, otherwise PS test. Okay.
So we can go with this as a thumb of rule, right, sir? Like
Yes.
if it is 1.96 equal, or I mean up to or more than, we'll go with this, right?
Yes, definitely, sir.
Thank you, sir.
Now, come to the next relationship of normality versus parametric test. Means what is the relationship of normality and parametric test? Why we need to check for normality for parametric test? So population is normally distributed. This is the assumption of parametric test. So parametric test can only be applied if population is normally distributed. Not normally distributed population or normality cannot be determined. Normality cannot be checked. We must go for non-parametric tests. Now, if you can see this graph, clearly it mentioned type of data categorical, you should go for non-parametric. If data is metric, are the data approximately normally distributed? No. Then go to non-parametric test. If data is near normal, because exactly normality of data cannot be determined in original data. Original means actual data. What we assume? We assume that data is near normal. Why I'm saying that near normal? If the calculated value is up to 1.96, then this is acceptable. Maybe by chance, we can assume that data is normal. If data is approximately normal, then if answer is yes, are the variance of population is equal? This arises if we have at least two set of data. If we have only one sample data, then this question does not arise. Are the variance of population is equal? If no, then also go for non-parametric. If yes, then go for parametric. So how many yes you have to see? Data should be metric. It must be normally distributed, and population variance must almost equal, not exactly equal, but almost equal. Then only you can go for parametric test. Otherwise, you should go for non-parametric test. Clear? Clear?
Yes, sir.
So
Yes, sir.
normality we have seen. How to check for normality?
Sir, can you please repeat it again? I didn't get it.
If you have data is categorical, go for non-parametric. If data is metric, you will ask again another question. Are the data approximately normally distributed? If answer is no, then go for non-parametric. If answer is yes, you will ask another question. Are the variance of population is equal? If answer is no, then go for non-parametric. If answer is yes, then only you can go for parametric test. This variance of population, the question arises if you have two set of data, means two data sets. If you have only one sample data, this question does not arise.
Sir,
Now,
sorry, sir.
yes,
So
please.
to ask you how to calculate variance of population. Is it like standard deviation, then we calculate variance, or something else?
For what? I will tell you. I will tell you. That will be calculated by software itself. You need not to calculate separately. But I will explain manually also. Don't worry.
Okay, sir. Thank you.
Everything I will explain. So parametric, non-parametric. So in case of data is interval and ratio, data is normally distributed and population variances are equal, then only we can go for parametric, otherwise non-parametric. Now, this is the list of tests. Purpose, why I'm applying this test. Should we go for parametric or non-parametric? Fitting of distribution, there is no parametric test. Chi-square test of goodness, you can apply for non-parametric. Exploring relationship, in parametric I can apply correlation. In non-parametric I can go for chi-square test of independence. Sapna madam, are you there? Sapna madam, are you there?
Yes, sir. Yes, sir.
So if you do not meet the assumptions of parametric, you have alternative non-parametric tests. So 2 independent sample t-test, Mann-Whitney u-test, several independent sample ANOVA, crucial Wallace test, 2 related sample paired sample t-test, Wilcoxon sign rank test, several related sample one-way repeated measure ANOVA, fragment test, correlation Pearson, Spearman rank correlation, data reduction technique, factor analysis, but we do not have any non-parametric test, but we do not have such kind of assumptions of parametric test. In case of factor analysis has its own assumptions. Okay, so this does not mean that you cannot apply any test. You can always apply test, but the power of parametric test is very high. Power of non-parametric test is not so high. That's why we always recommend you to apply parametric test. So parametric test we have discussed a lot. This is also we have discussed. 1 sample t-test, z-test, 2 sample independent samples, 2 group t-test, z-test, paired mein t-test we can apply. So assumptions, normality, we have checked normality. If there are 2 or more than 2 samples, another assumption is the homogeneity of variance. Variance among population is assumed to be same. If it is same, we can go. Same means similar, not exactly same. So what is homogeneity of variance? Somebody asked this question, how to check for homogeneity of variance? Means variance among both the data set are equal or not. We should check. Test in SPSS will automatically check for this homogeneity of variance, but we must understand what is this. Variance is a measure of dispersion of random variable about the mean. If I say it indicates how far the values spread out, variance, it refers the variance within each of the population is equal or not. So homogeneity of variance will be checked by the test known as Leibniz test. T-test and ANOVA uses Leibniz test by default. You need not to select anything, but T-test for more than 2 categories and ANOVA will automatically check for Leibniz test, and you have to see whether there is a homogeneity of variance or not. If homogeneity of variance is there, then you should see the results of T or ANOVA. Otherwise, no. Now, we have the file. We will apply these tests. So student t-test, as we know, this t-test is known as student t-test. Why we apply this test, 1 sample t-test? To check the claim. What are the conditions? The sample size is small. When data values are independent and arise from random sampling, population variance is known. Sorry, not known. Population variance is not known. The underlying distribution of population is normal probability distribution. Underlying distribution is normal probability distribution. You have one file. Is my screen shared or not? It's shared. Okay.
Sir, I don't have any data sheets. Actually, I could not join yesterday.
Okay. You do not have any data sheet.
Yeah.
Okay.
Anyway, I'll take it from.
Can you write me your email ID here?
Sure, sir. I will. Thank you.
I will just forward the email to you. Okay. So what will be the null hypothesis? What will be the null hypothesis in case of? I'm just forwarding you. Give me 1 minute. Okay, please check.
Okay, sir. Just a minute. Thank you, sir.
Okay. So we have one file. The file name is one sample t-test. But what will be the hypothesis, null hypothesis in this case? What will be the null hypothesis in this case? Null hypothesis will be there is no significant difference between sample mean and population mean. I'm repeating. What will be the null hypothesis in this case? There is no significant difference between sample mean and population mean. So let me see. There is a company which claims that each packet of biscuit is of 50 gram. Company claims that weight of each packet is 50 gram. And I want to check whether the claim of the company is true or not. So what I do, I will randomly collect certain packets of biscuit. I will weigh them and I will note down the weight of each packet. Do we have that file? One sample t-test. Sorry, one sample t-test. You have. So I have taken randomly 10 packets of biscuit. This is serial number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is the weight of packet number 1, 55. Packet number 2, 54, 58, 52, 48, 50, 54, 55, 56, 50. I want to check whether the claim of the company is true or not. What is the claim of the company? The weight of every packet is 50 gram. So I will check with the help of one sample t-test. Can anybody tell me how many variables in this data? How many variables are there in this data?
Only one.
Only one.
One, sir.
That is weight.
Weight.
Serial number is not a
Variable. It is
data
not
or variable. So I will go to analyze. Compare means one sample t-test. I'm repeating. Analyze. Compare means one sample t-test. I will click. What is my test variable? Weight. And what is my test value? What is the claim of company? What is the claim of company?
Every packet is
50,
50 grams.
50 grams. So I will give the value 50 here. Okay. Then click OK. I will get results. Are these results visible to you? Are these results visible to you? Okay.
Yes, sir.
So first one is one sample statistics weights in gram. This is number n means the sample. This is mean 53.8320. This is standard deviation. This is standard error. What I want to check whether this mean is significantly different from the claim value that is 50 or not. Am I right or wrong?
Yes, sir.
What is my
Yes, sir.
objective?
Yes.
Yes, sir.
What is my objective? To check whether the mean weight of these packets of biscuit is significantly different from 50 gram or not. Okay. So what I will do, I will see this table, one sample t-test. Is it visible?
Yes, sir.
Visible
Yes,
or not?
sir.
Yes, sir.
Otherwise, I have pasted these tables on PPT also. Now, same table I have pasted here. Are these visible to you? So I can
Yes, sir.
I can check this with the significance level. What is my significance level? 0.02. 0.002. What it suggests me?
Not significant.
0.05.
0.002. What does it suggest me?
Except null hypothesis.
It's not significant.
98%.
Not significant.
Whether I will be able to accept my null hypothesis, there is no significant difference between sample mean and population mean. Am I able to accept or reject my null hypothesis?
Accept the.
Yes, sir. Accept, sir.
Accept.
Yes.
Okay. If my significance value or
Sir, reject the null hypothesis.
p value is less than 0.05,
Less than
What is
0.05.
I'm able to reject my null hypothesis, or we can say null hypothesis is not accepted.
Not accepted.
If my null hypothesis is not accepted, then what does it mean? There is a significant difference between the sample mean and population mean. It means the claim of the company is not true. Claim of the company is not true, because company claims 50 gram and the value is 53.83 gram. So the difference is statistically significant. The difference is statistically significant. The claim of company is not true. Yes. You are writing any question?
Yes, sir. In my screen, there is like under significance, one side P and two side P. In one side P 0.001 and two side P it's 0.002.
In one side, what is the answer?
0.001 and in two side P.
Then also you are able to reject it. But we see the two tail. Okay. If it is less than 0.05, then we are not able to accept the null hypothesis.
Sir, I'm still not able to understand
What?
which value we are.
Okay. This significance value means this is p value. Significance value means p value.
So isn't it less than 0.05?
Yes. Then should I accept my null hypothesis or reject my null hypothesis?
So show the null hypothesis once.
Okay. Null hypothesis is there is no significant difference between sample mean and population mean.
We will accept null hypothesis.
We will accept.
Yes.
Why?
Because the significant value is 0.02, which is less than 0.05.
So in case the value is less than 0.05, we accept the null hypothesis.
No, reject the null hypothesis.
We are not able to accept the null hypothesis. Or we can say
It will be rejected, sir.
It will be rejected.
Yes.
That's why I'm saying that there is a significant difference between the sample mean and population mean. So claim of the company is not correct. And we have three parameters to check the answer. Three parameters. Listen carefully. First one is T statistics. If this T statistics is, this is calculated T statistics. If it is more than the table value, it means we are not able to accept the null hypothesis. Okay. If it is less than the table value, then we will say that we are not able to reject the null hypothesis and null hypothesis has been accepted. So one method is T.
Excuse me, sir. Here, what is the table value?
What is
Table value 1.96.
So that remains a standard with everything, sir.
Yes, for 5%. For 5%. Okay. And third method. If we find 0 between lower and upper limit, if we find 0 between lower limit and upper limit, what we will interpret? If we find 0 between lower and upper limit, we are not able to reject the null hypothesis. If we do not find 0 between lower and upper limit, then what we will say? We reject the null hypothesis. When we will find 0, if one value is negative, another value is positive. So we have three methods, and for your convenience, I've written here, if calculated T value is less than the table value of T, null hypothesis accepted. In this case, the significance value must be more than 0.05. If this T value is less than 1.96, significance value must be more than 0.05. Okay, and we will find the 0 between lower and upper limit. Done. Clear?
Clear, sir.
Okay. I have two more files. If you have, software, then please check. I have two more files. Means one file. In that file, we have two data sets for weight, 100 gram, and another data, the claim is for 90 gram. Open the file, one sample t-test. And for this, open the file, one sample t-test file 2. I'm opening that file. Okay. Is the file visible to you? Is the file visible to you?
Yes.
We have one observation and we have second observation. In the first observation, the claim is 100 gram. In the second observation, claim is 90 gram. So we'll check separately. Go to analyze, compare means, one sample t-test, transfer one variable, and test value is 100 gram. Okay. See the results. My significance value is 0.409. I'm able to accept null hypothesis. There is no significant difference between sample mean and population mean. And you can see the mean value 100.03 gram. My statistical analysis suggests me that this difference may be by chance. So I cannot say that this is statistically significant difference. Clear? Please respond. Please speak because I'm not able to see your screen. Yes. Is it clear or any doubt?
Clear, sir.
Okay. So another data set I have. Another data set I have. Wait. Go to analyze. Compare means, one sample t-test. Now I will transfer another variable and my test value is 90 gram. I will click OK. These are the results. Tell me whether you are able to accept null or reject null. Null is accepted.
Accepted.
Accepted. So my mean value is 89.9820. So the difference may be by chance. The difference is not statistically significant. I think you got the idea. What does it mean? Okay.
Since it is more than the p-value, sir.
Sorry?
Since it is more than the p-value, it is not accepted.
Since it is more than the
P-value, the significance.
no, more than 0.05.
0.05, yeah.
That's why I'm not able to reject null. Okay. So for your convenience, I have pasted all the results on PPT. I will share that PPT at the end of FTP. Now come to the two independent sample t-test. What does it mean? I have two samples and both samples are independent. Both samples are independent. Now the role of homogeneity of variance comes into the picture. So what is the homogeneity of variance? Try to understand the null hypothesis of Leibniz test. Leibniz works for standard deviation homogeneity. What is the assumption of Leibniz? Is equality of variance. Means it assumes null hypothesis is variance is equal. It is known as homogeneity of variance. Standard deviation of both samples should be comparable. When we say equal, not exactly equal, but it must be similar. So see the two data set. There are, two hotels. One is selling tea at ₹10 per, tea. So during the day, this hotel is able to sell 5 cups of tea. Are you getting my point? There is one hotel X which sells tea at the rate ₹10 per cup, and during the day it is able to sell 5 cups of tea. What it earns, that is 50 rupees. Clear? And another, sorry, another one, the hotel is known as Y. It sells the tea at the rate of rupees 50 per cup. And during the day, it is able to sell only 1 cup of tea. So if you see five customers visited, but only one ordered for tea. If you see, the mean value of both the hotels is rupees 10 per customer. Mean value means per customer. 5 customers visited here, everyone ordered for tea. 5 customers visited here, but only one ordered, for tea. So revenue collection for both the hotels is 50 and observations are 5, then mean value is 10 and 10. But standard deviation, if you calculate, there is no deviation here. There is no deviation, but in this case, the deviation is 22.36. So standard deviation of variance of these two data sets is not comparable. One data set has 0, while other data set has 22.36 as variance. So what we will do? We cannot apply parametric test in this case. Look for another kind of data. One company makes advertisement. So advertisement category is 222111. 2 means high advertisement expenditure. 1 means low advertisement expenditure. We have given the codes up to this amount. The expenditure will be assumed to be low, and after this or beyond this or more than this amount, the expenditure will be assumed to be higher expenditure. So we have given the code 1 to lower expenditure, 2 to higher expenditure, and we have rearranged the data here. Category 2 means high expenditure, and this is the corresponding sales, and this is category 1 means low advertisement expenditure, and we have the sales observations here. We have calculated mean. The mean is different, means 86.9 and 72.13. But when we calculated standard deviation, you can see the standard deviation is 3.479, 3.314. So this standard deviation is comparable, not exactly same, but it is almost similar. It is comparable. Then we can go for the parametric test. We can go for 2 independent sample t-test because we have 2 independent samples. One sample is for high category, another is for low category. So the company is interested to know whether there is a significant difference in the sales on the basis of high advertisement expenditure and low advertisement expenditure. Is my question clear to you? Hello? Hello? Is my question clear
Yes,
to
sir.
you? Okay.
Yes.
So now we will check it with the help of statistics. So in this case, what will be my null hypothesis? Mean 1 and mean 2, the no significant difference between two population means. What will be my alternative hypothesis? Mean 1 and mean 2 are not equal. The population means are different. So we have one file, and the name of file is 2 independent sample t-test. Do you have this file? Open the file. The same data has been entered here. Is it visible? Hello? Hello?
Yes, visible.
Yes, sir.
Go to analyze, compare means and independent sample t-test. So what is my test variable? Test variable is sales. What are my categories? Group category, and I will define my categories. Group 1 means 1, group 2 means 2. Because I have given the codes like 1 and 2, if I have given the codes like 5 and 10, so I must have written 5 and 10 here. So continue. Okay. then these are the results. So what is group statistics in low category? I have 8 observations. In high category, I have 10 observations. This is the mean which I have calculated. This is the standard deviation which I have already calculated. Now come to the independent sample test. So this is Leibniz test for equality of variance. Leibniz test for equality of variance. So what is the thumb rule? Please see on the PPT. If significance is less than 0.05, means unequal variance. Okay, significance of what? Leibniz test. Because what is the null hypothesis? Leibniz test for equality of variance. This assumes that equality of variance is there. So are we able to accept the null hypothesis or reject the null hypothesis? Hello? The null hypothesis is equality of variance is assumed. So are we able to accept null or reject null?
I think accept.
Accept. If we are able to accept, means equality of variance is there, then we should see the t-test results. If equality of variance is not there, we should not see the t-test. Okay, because we cannot apply t-test in that case. Software will apply, but theoretically you cannot apply. Is it clear?
So
Now,
could you repeat that one?
first of all, you will see the result of Leibniz test. So what is the null hypothesis of Leibniz test? Equality of variance assumed. You see the significance level of Leibniz test. Are we able to accept null or reject null?
Here accept.
Sorry?
Sorry, here accept.
Accept. It means there is equality of variance. If equality of variance is there, then you can see the test for equality of means t-test you can see. If you are not able to accept the null, then you should not go for t-test. So in case of t-test, you see equality of variance is assumed and we are able to find equality of variance. So we will see the first row. Which row? First row we will see. So see the significance to tail 0.000. In this case, we are not able to accept the null hypothesis. And what was by null hypothesis? There is no significant impact of advertisement on sales. So we are not able to accept that. It means there is a significant impact of advertisement on sales. If advertisement is high, then sales will also increase. If we keep the advertisement low, then sales will be low as compared to other categories. Okay. Any doubt? Any question? No? Should I move ahead? Okay. So third is paired sample t-test. What is paired sample t-test? When we collect the data in pair. Pair means before, after, pre-event, post-event. Yesterday we have discussed a lot about this experimental analysis. So if we are collecting the data before, after, or we are collecting the data pre-event or post-event. So in case of experiments, we can collect the data before experiment and we can collect the data after experiment. But in this case, data sets are not independent because we are collecting the data from the same set of respondents. We are not changing the respondents. In independent sample, what we do, we collect the data from 2 different independent samples. But in this case, we collect the data from the same set of respondents before the event and after the event. For example, any training program, we are collecting the data from the same set of respondents before training program and after training program. Any exercise, any diet plan, any administration drug, etc. In this case, we collect the data from the same set of respondents prior to event and post event. Clear? So I have data of stock market. In this case, you must have the file with the name of stock. Do you have this file, stock?
Yes, sir.
So
Yes, sir.
go to analyze. Compare means paired sample t-test. Paired sample t-test. Okay. Now you can make the pairs as per your choice. I have the data of stock market. I have date. I have close price. I have high price. I have low price. I have volume. So date does not mean as a variable. So I can make the pair of close, high, low. Whether my close or low are different, whether my high or low are different, whether my close or high. So whatever I want to make as pair, I will choose here and I will put here close and high. I have made one pair, close and high. Second pair may be low and high. Third pair maybe low with close. And high and low. Okay, so 3 pairs I have made. I will click OK. Then I will get my results. So these are the pairs. I have made pair of close and high. Are you able to see this window? Hello?
Yes,
Yes,
sir.
sir.
Okay. I have made 3 pairs, close and high, close and low, high and low. And these are the observations. These are the mean, standard deviation. This is the paired sample correlation among the pairs, 0.998, 0.999, 0.998. So this is my paired sample statistics. I will see the significance. So there is no significant difference as null hypothesis, but I can see the significance value, p value. All the p values are less than 0.05. So I'm able to reject my null hypothesis. There is a significant difference between close and high, close and low, high and low. There is a significant difference. So I have taken stock market data in this case. You can take any kind of data. So we have covered today hypothesis, objectives, types of analysis, then the questionnaire, how to frame questions, then scale, and assumptions of parametric test. And we have applied t-test, one sample t-test, independent sample t-test, and paired sample t-test. As per schedule, we need to cover ANOVA also today, but I think tomorrow we can take it up with ANOVA, and today we want to stop here. We are open to queries. If you have any kind of query, we can discuss that query. Otherwise, we can stop here for today. Any query? Which file?
So yesterday I could not attend the session as
Yesterday I have not shared any file because hands-on was not there yesterday.
Okay.
So I have shared file today. I will share files for tomorrow also. Tomorrow I will share those files.
Thank you, sir. Sir,
And
please can we get today's recording?
Recording, Saurabh sir will share the recording with all of you.
Okay.
Get it tomorrow.
Thank you,
Just
sir.
like you did.
Thank you.
Any other question?
Thank you, sir.
Okay.
Thank you so much.
Over to you, Saurabh sir.
Okay, thank you. I think the meeting is over. All of you can leave. Thank you, Professor Anil, for such an enlightened session. And I also thank participants for such enthusiastic participation. So the now meeting is over. All can leave. Thank you.
Thank you, sir. Thank you.
Sir,
Thank you all.
today's recording will be available at what time?
Tomorrow. Priyanshi, tomorrow.
Tomorrow before 2 p.m.
Okay, sir.
Okay, thank you. Thank you, everyone.
Thank you, sir.
Thank you, sir.
All can leave the meeting now.